Now we are going to solve a question that is based on that connected particles. So two particles P and Q has masses 4m and 2m respectively. The particles are connected by a light inextensible string. A second light inextensible string has one end attached to Q. Both strings are tight and vertical as shown in the figure. The particles are accelerating vertically downwards. So here they are mentioned the particles are accelerating vertically downwards. So this is moving vertically downwards like that. So we can mark it as A. So given that the tension in the strings connecting the two particles is 3 mg, find in terms of m and g the tension in the upper string. So there are two different things. This is the upper string. So here this string has a tension like this. So I can mark it as TQ. And here the string which is connected in between the two particles, it can create a tension like this. So this is, I can just mark it as T and T. These two tensions are same in magnitude and different in direction. So here we can able to write this is 3 mg and this is also 3 mg magnitude. So this value is given in the question. Now they mention that Q has 2m mass, so that a weight force which is added at the point Q, that is 2 mg, and a weight which is here in that P, it is 4 mg. Okay, so these are all the forces are acting on the object. Now we are going to calculate the tension in the upper string in terms of m and g. So once I am starting that question, I want that A value, then only I can able to calculate the TQ. So that I am going to take that P particle separately to calculate the A value. So that I take it as particle P, and this particle P has 4 mg weight force towards downward and only one tension upwards, that is T is equal to 3 mg, and the particle is moving downwards. So we can able to write it as the downward moving forces are positive and F is equal to ma. Because the object is moving downwards, I am taking the downward directions are positive. Then 4 mg is a positive force, and then minus 3 mg, it is a negative force because of that upward direction. The mass of that particle P is 4m, so it is 4m times A. So now I can simplify this one. So this will be mg is equal to 4ma. So I want that A value. So A equal to mg divided by 4m. So mm get cancelled. This will be 1 by 4g. So we calculated that acceleration value is equal to 1 by 4g. Then second, we need to take it as that particle Q to identify the tension in the upper string. So if I am taking this is particle Q, it has a tension towards downward, that is 3 mg, and a weight force towards downward, that is 2 mg, and there is a tension towards upwards, so we mark it as TQ. This is the thing we need to identify, and the object is moving downwards with the acceleration A. So for this particle also it is moving downwards, so downward direction is positive, F is equal to ma. So the forces are acting on the object, it is 2 mg is a positive force plus 3 mg is also a positive force because both the forces are downward direction, and then minus TQ, it is upward, is equal to the mass multiplied by acceleration. The mass value is 2m, so it is 2m times A. Now we can able to solve it. This will be 2 mg plus 3 mg, this is 5 mg, then minus TQ is equal to 2m times 1 by 4g. So we can able to solve, this is 1 times 2 and 2 times 2, so 5 mg minus 1 by 2g is equal to TQ. So I take this minus TQ to the right hand side as positive TQ, then this 1 by 2g I took it as to the left hand side, so it is 1 by 2g m, so it is mg. So when we are subtracting this 5 mg with that 1 by 2 mg. So this will be like 4.5 mg. That is the value of TQ. Okay, so we can check that 5 minus 1 by 2, answer will be 9 by 2. 9 by 2 is 4.5, so that 4.5 mg as our final answer. This is the tension in the upper string in terms of m and g.